Another common situation that we see in percent change problems is this. We know the starting amount and the percent change, and we want to find the final amount. Now again, we have two strategies open to us. We can find the amount change and then add or subtract to find the final amount, or we can find the final percent and then use a proportion to find the final amount. Now, like before, finding the amount change and then adding or subtracting to find the final amount is going to make the arithmetic a little bit easier. And so again, we're going to prefer this method. However, if you decide to use this strategy, it's also correct. It also works quite well. Let's see an example of a problem of this kind. Suppose a small town's population was 28,000 in the year 2000. By 2010, it had decreased by 47%. What was the population in 2010? Well, here we're interested in the years 2000 and 2010. So 2000 is where we start. 28,000 is our starting amount. The percent change is 47%, and it was a decrease. And what we want to know, what is the population in 2010? We want to know the final population. Our strategy is going to be to find the change in the population, and then, since this is a decrease, we'll subtract to find the final population. So, to find the change in the population, we'll say our unknown amount change over our starting amount is our 47% over 100. We'll cross multiply. X times 100 is 28,000 times 47. Doing this multiplication, that's 47 times 28 with 3 zeros on the end. 7 times 8 is 56. 7 times 2 is 14. Plus 5 is 19. 4 times 8 is 32. 4 times 2 is 8. Plus 3 is 11. And then 3 extra zeros on the end. X times 100 is 1,316,000. I find that x times 100 is 1,316,000. What times 100 gives me this number? Canceling some zeros, I find that I get to divide by 1. X is 13,160. One pitfall of this strategy, it's really tempting at this point to think we're done. But we're not, are we? We still need to find the final amount. This was a decrease, so in order to find the final amount, we'll need to subtract our 28,000 minus our 13,160. 10 minus 6 is 4. 9 minus 1 is 8. 7 minus 3 is 4. 2 minus 1 is 1. So, the population in 2010 was 14,840. Let me give you one of these to try. Suppose Sarah spent $1,580 shopping on Black Friday last year. This year she plans to spend 15% less. How much will she spend this year? Pause the video and try this now. So we're going from last year to this year. So our starting amount was $1,580. This year she plans to spend 15% less. So that's 15%, and it's a decrease. And we want to know how much will she spend this year. So we want to know this year's total. In order to answer this, we'd like to first figure out the amount change. So we'll set up our proportion. The unknown amount change over the starting amount is 15% out of 100. Cross multiplying, we have 100 times x is 1580 times 15. We'll need to do this multiplication, 1580 times 15. I'm going to do that as 158 times 15 with a 0 on the end. 5 times 8 is 40. 5 times 5 is 25, plus 4 is 29. 5 times 1 is 5, plus 2 is 7. 1 times 8 is 8. 1 times 5 is 5. 1 times 1 is 1. 0, 17, 13, 2, and then that extra 0 on the end. 100 times x is 23,700. 100 times what is 23,700? Well, 23,700 divided by 100, canceling some zeros, we get x is 237. Now again, the most likely mistake to make in a problem of this type is to think we're done at this point. Right? We're not done. Why? Because what we're looking for is the final amount. So that'll be 1,580. It was a decrease, so we'll subtract 237. 0 minus 7 I can't do. 10 minus 7 is 3. 7 minus 3 is 4. 5 minus 2 is 3. 1. Sarah plans to spend $1,343.